Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So this is a continuation of our Huawei Lab simulation series, and in this episode we'll be focusing on how to implement QinQ on Huawei routing and switching devices. So we know we have different implementations for VLAN tagging on a service provider or enterprise network. So we have the traditional 802.1EQ that allows us to add one VLAN tag on IP packets. So we only add one VLAN tags. But then we have the new standard, the QinQ standard, that allows us to add multiple VLANs. So it allows us to do VLAN stacking, adding multiple VLANs on one IP packet. So in this episode, we'll be focusing on how to implement QinQ on Huawei devices. But before we dive into the lab, we need to have a basic understanding of the QinQ encapsulation. So I've mentioned that traditionally we have the 8.2.1Q that allows us to add one VLAN tag on IP packets. The 8.2.1Q supports only 4094 VLANs. So when a service provider has many customers, and we know all service provider networks have grown and they require more than 4094 VLANs. So the 802.1Q is limited in the VLAN space. They are not enough to serve many customers or many services on our service provider networks. So that's why there was the invention of the 802.1AD that adds an additional 802.1Q tag to a single tagged 802.1Q packets. So we are doing what we are calling the VLAN stacking. We are adding multiple VLANs on one IP packet. And this one expands the VLAN space to 4094 times 4094. So we are having many VLAN that we can use on our service provider network, and we are not limited anymore to only 4096 VLAN that are supported by 802.1Q tagging. So the QinQ implementation has been adopted by many networks because it's providing a bigger VLAN space. So there are some application scenarios that we can use QinQ. The first one is when we want to expand VLAN space. When we want many more VLANs than 4096, then we can use the QinQ application that allows us to use the 4094 times 4094 VLANs in total. So we have a bigger VLAN space. Then with QinQ, we have the inner and the outer VLAN tags. So these VLANs can be used on service provider networks to differentiate users and services. So we have the inner VLAN that will be used to identify users, and then we have the outer VLAN that will be used to identify services as they are flowing on the network. Then we also use QinQ that can provide symbol VPNs, because remember I've mentioned that we have the inner tag and the outer tag. So the inner tag of the QinQ packets can be transparently transmitted over a carrier's network. So we can use it as a way of symbol VPNs to encapsulate the customer traffic and then transmit it transparently on our carrier network. So as you can see on the left, we have an IP packet, of course, but with 802.1Q, we are adding just one tag. So we are adding one VLAN tag up here with 802.1Q, but with QinQ, we are adding two 802.1Q tags. So we are transmitting one tag within another. So they are stacked. That is what we call the VLAN stacking. So we have the inner VLAN and the outer VLAN, or the inner tag and the outer tag. So when we do a packet capture for 802.1Q, you can see that we only have one 802.1Q encapsulation. But with the QinQ encapsulation, we have two VLANs. We have two VLAN tags. We have the inner VLAN tag and the outer VLAN tag. So we have been able to expand the VLAN space. And this is very common on service providers. Sometimes the customer doesn't want to just use one VLAN. Sometimes they want to be allowed to use multiple VLANs. and not just be limited to using one VLAN. So they will send in a request and request that they need to implement QinQ. So you need to define the outer VLAN and the inner VLAN that the customer can use to transport its services over the service provider network. So with this discussion, we can now start our lab simulation. So this is our lab setup, and you can see that we have the MPLS backbone with PE01, P01, and PE02. In our MPLS backbone, we'll be running MPLS and also IGP, ISIS. We'll be configuring ISIS as our IGP and enabling it on the interfaces. So we have indicated the IP planning, we are having the loopback zeros, and then we have CEs. We have two CE. We have CE01 connecting to PE01, and then we have CE02 connecting to PE02. So in this setup, we'll be using an outer VLAN of 500. So let me just indicate that we have outer VLAN of 500. And then we'll be allowing the customer to use VLANs from 1 to 500. So the customer can choose any VLAN from 1 to 500, and then that will be used at the inner VLAN while the services are being transported over our service provider network. So on the CEs, to simulate this QinQ, we'll be configuring sub-interfaces on the CEs, and then we'll configure one for 200, 300, and then 600. 600 to simulate that if this VLAN is not in the allowed VLAN range, then the services will not traverse our network. They will be denied because the outer VLAN is out of the range. So for the configuration steps, these are the configuration steps that we'll be following. The first step, we need to configure ISIS on our network. Remember, we need to have reachability from PE01 to PE02. So we'll be configuring IGP, ISIS as our protocol. And then we need to enable MPLS and MPLS LDP globally on all the routers in MPLS backbone. After we have enabled MPLS and IGP, we can now configure interfaces so that we will be enabling IGP on the interface and also enabling MPLS and MPLS LDP on all the interfaces in our MPLS backbone. Now, once we have finished configuring interfaces, the next step is now to configure LDP, remote peering session between PEs. So before we configure VPLS or layer 2 VPNs on the boxes, we need to have LDP remote peering sessions between the PEs. Remember, they are not directly connected, so that's why we are configuring remote peering sessions between the PEs. And once we have the remote peering sessions, we can now configure VPLS on the PEs, the virtual private LAN services. These are layer 2 services that we will be using to implement this QinQ encapsulation. And once the VPLS are up, we can now configure interfaces facing the customer and bind VSI on the port. So we are binding the VSI or the VPLS on the interface facing the customer. And the final step of our implementation will be to configure the CEs and then carry out verification that our services are running okay by doing a ping from C1 to C2 just to verify that our QinQ is working okay. So this lab, I haven't configured anything, so we'll be doing the configuration step by step so that we get to understand each and every command. So to start us with, we'll start by configuring the ISIS, and then we'll do MPLS as I mentioned in the steps. So we'll start with PE01. So on PE01, I've just configured the name. We need to configure ISIS. For ISIS, there are some commands that we need to run. So the first command that we need to run, I've mentioned that we are using ISIS 100. So we need to configure ISIS process 100. In this ISIS process 100, we can configure the name. So we'll give it the name of PE01 for easy identification of the peering sessions. And then we need to configure the level. So we'll be using level 2. So it is IS level. It's level 2. I will also change the course style to wide. And then we need to configure the network entity. So for the network entity, we'll be generating it from the loopback interface. So it's 49.0010.0100.1001.000. So the selector is still 100. So once I've configured this ISIS, I can display this to verify that it's well configured. So these are the configuration for ISIS on our P01. And then we need to enable MPLS. When we are doing MPLS configuration, the first step is to configure the LSR ID. And the LSR ID will be the loopback 0 IP. So we need to configure the LSR ID of 1.1.1. Once we've done this, we can now go ahead and enable MPLS. And we also need MPLS LDP for label distribution. So I will enable MPLS LDP. And remember, VPLS is a layer 2 VPN. So we also need to enable MPLS L2 VPN on our router. So I will commit. So now with the IGP and MPLS enabled, we can now start configuring our interfaces. So the first step I will do is to configure the loopback interface. So I will get loopback 0 and IP address will be 1.1.1.1, mask is 32. Mask is 32, I will commit. So we have configured our loopback interface. The next is to configure the physical interface, Ethernet 1/0/0. I'll give it an IP address of 10.10.10.2/31. And then we need to enable MPLS and MPLS LDP. You always have to enable all the interfaces. If you fail to enable one of the interfaces, the service will fail to come up. So you need to be keen when you are doing this configuration. So we'll enable ISIS 100 on this interface. And I also need to enable ISIS 100 on loopback 0. If I check, I haven't run this command, so I will enable ISIS 100. So with ISIS enabled on the interface, on the two interfaces, loopback 0 and the physical interface, we can now go to P01. Remember, we have configured MPLS, we have enabled it on the interface, we have configured ISIS, we have also enabled it on the interface. So on P01, I will also configure ISIS, so I will configure ISIS 100. IS name will give it P01. Network entity will be 49.0100. This is the loopback IP is 2.2.2.2. So that one gives us 0020.0200.2002.000 at the selector. Then I will configure the cost style to be wide. I will commit and then we can verify, display this. Cost style wide, we need to configure the level. IS level is level 2. I will commit again, quit. So once you've configured IGP, we need to configure MPLS. So we need to configure the MPLS LSR ID, and we are using the loopback 0 IP. Now we can enable MPLS, MPLS LDP, and MPLS layer 2 VPN. So once we've done this configuration for ISIS and MPLS, we can now go ahead and do the interface configuration. So I'll start with loopback 0. IP address is 2.2.2.2/32. ISIS enable 100. So remember, we are just configuring our backbone for now. So another interface, we have interface Ethernet 1/0/0. I will give it an IP address of 10.10.10.3/31. And then we need to enable ISIS 100, MPLS, LDP. So that is it for this interface. We can go to the other interface facing P02. 1/0/1. We need to give it an IP address of, let me move this one slightly so that we have a clear view of the topology and so we are just configuring our MPLS backbone. I will move this one slightly. IP address for that interface, it should be 10.10.10.0, mask is 31, and then I will enable MPLS LDP, and then we need to enable ISIS 100. So I can do a commit. So that is it for our P01 configurations. Then the next router that we need to configure is P02, our provider edge router 2. So I will configure ISIS 100. IS name is P02. I need to configure the IS level to level 2. Cost style should also be wide. And then the network entity. Network entity will be generated from loopback 0, so it's 49.0.030.0300.3003.00. So I can commit and just verify the SIS configuration. So once you've configured ISIS, same process, we need to enable MPLS. So I'll configure the MPLS LSR ID and then enable MPLS LDP. So we'll be using LDP as our signaling protocol. That's why we are enabling it on all the routers and all the interfaces. Then we need to enable MPLS layer 2 VPN. Because VPLS, again, it's a layer 2 VPN. So once you've done this, we can now proceed to configure interfaces. So we'll start with loopback 0. IP address, it's 3.3.3.3. Mask is 32. ISIS enable 100. And then we need to configure the physical interface. So we only configure the interface that is facing our MPLS backbone. So we have interface Ethernet 1/0/0. I will assign an IP address of 10.10.10.1. Mask is 31. And then we need to enable MPLS LDP. And then we enable ISIS enable 100. So we have completed configuring IGP, MPLS, and our interfaces. So if I display ISIS peer, we have one ISIS peering session coming up. On P01, we expect to have 2 ISIS peering sessions. ISIS peer, we have one. Let me check. How about the other facing P01? So we have the one for P02, it's up. I'll display ISIS interface. We have Ethernet 100 and 101, that is up. Display ISIS peer again. So we still have one. Display IP interface brief. So you need to be able to run these commands and troubleshoot. Maybe you missed an IP address or you did some misconfiguration on the interface. So it's always good to know these commands so that you can be able to troubleshoot on your own during the implementation. So I can check on P01 also, display ISIS interface. Display ISIS interface. So we don't have ISIS enabled on any of these interfaces, or maybe I didn't do a commit. So display ISIS interface. Yes, I missed a commit on this router. So you can see how you can easily troubleshoot when you are having such issues in the network. So if I display ISIS peer, I expect the peering to come up. On P01, we should now have two peering sessions. ISIS peer, we have two sessions. You can do verbose, and it will give you more details about the peering session between the routers. So you have two peering sessions to P01 and P02. So from P01 now we should be able to ping the loopback of P02. So we are able to ping, and from P02 we should be able to ping the loopback of P01 before we move to the second step, to the next step of configuration. So at this stage we have reachability, we have connectivity in our MPLS backbone. We can now go ahead and start configuring LDP remote peering session. So on P01, if I display MPLS LDP peer, we only have the connected peering session between P01 and P01. On P02, it's the same. Display MPLS LDP peer. We only have one session to P01. On P01, we expect two MPLS LDP session. LDP peering, we have two. One to P01 and another one to P02. So if we were to configure our VPLS from P01 to P02, it will not come up because they don't have this LDP session. So that's why we need to configure a remote peering session between the Ps. And the configurations are very simple. So on P01, we need to run MPLS LDP remote peer. And then you can give a string, but many times we prefer to use the IP of the remote peer. So I will use 3.3.3 as the name, remote peer name. And then we need to configure the remote IP. So the remote IP will same be 3.3.3.3. So I've finished configuring the remote peering session between these two. If I display MPLS LDP remote peer, you can see that we have a peering session, it's active, but we also need to configure P02. So on P02, we can configure MPLS LDP remote peer, and I will use 1.1.1. And then we need to give the remote IP of 1.1.1. So we have configured the remote peering session between P01 and P02. We can verify that they are up. Display MPLS LDP peer. You see that before we had only one peering session, but now we have two. One is local, another one is a remote peer. So on P01, we also expect the same. Display MPLS LDP remote peer. We have a remote peering session. Display MPLS LDP peer. This one also has one remote peer. So this one confirms that our LDP sessions are okay, and we are able to exchange the labels from P01 to P01 and P02. So the next step of configuration is now to start configuring our VPLS. So our VPLS will be configured on P01 and P02. For the VPLS, we are configuring what we are calling the VSI, the virtual switch instance. And then this virtual switch instance will be used to bind, or will be bound on the interface facing the customers for us to be able to achieve the objective of our lab. So the first step we need to configure is to configure a VSI. So we configure VSI. You can see that you use a string, and indicated that our VSI ID will be 500, which is our VLAN ID, the outer VLAN ID that we are configuring for our QinQ. So once we've configured the VSI, you can give it a description. For example, I just give it test VSI. And then we need to configure the encapsulation. So you see that we have different types of encapsulation. You can either use Ethernet or VLAN. In this setup, we are using Ethernet encapsulation. So I can commit. If I display this, you can see that we have the description and the encapsulation. But this will not be able to bring up our VSI. So we need to do further configuration. We need to configure our signaling protocol. So we have what we call the pseudo-wire signaling protocol. And then you see that you can use LDP, you can use BGP. In this setup, we are just using LDP as our signaling protocol. So once we have configured our signaling protocol, we need to configure our VSI ID. And the VSI ID should be merging on both ends. So if we use 500 on PE01, we should use 500 on PE02. So I will configure 500 as my VSI ID. And then we can specify the peer IP, which should be the IP of the remote PE. So we'll use 3.3.3. Commit. So these are the configuration for VSI. Display these. We have configured the description, the signaling protocol LDP, and configured the VSI ID and the peer IP address, and specify the encapsulation mode to be Ethernet. So with this, we can now check the status of our VSI. If I display VSI name 500, you can see that our VSI is currently down. It's not up because we need to do similar configuration on the far end. So on the far end, that is P02, I will get VSI 500, give it a description of test VSI, and then we need to configure the encapsulation mode to be Ethernet, and then we configure the signaling protocol to be LDP. Once we've done this, we can configure the VSI ID of 500. Remember, I have mentioned that it should be merging on both ends. And then we can configure the peer as the IP of P01. So we have finished configuring our VSI. On P01, if I display, I'll just recall the same command. Still down, still down. Let me check. I need to commit. Display VSI name 500. Still down because we haven't bind any access interfaces. So we have already configured the VSI, but we need to go ahead and use this VSI on the customer facing interfaces before it comes up. So we have completed configuring VPLS on PEs. The next step is now to configure the interface facing the customer and bind the VSI. So this is where it gets somehow tricky because you need to specify the inner and the outer VLANs. So on P01, we need to configure the outer VLAN facing the customer. That is the only configuration that we need to do facing the customer. So the interface facing the customer is Ethernet 1/0/1, and we are doing .500, which is our outer VLAN. So we are creating a sub-interface with VLAN 500, which is our outer VLAN, VLAN type .eq 500. Once we have done this, we need to configure the QinQ VLAN. Oh, I'm missing something. Let me display these again. Commit. So remember, this is a setup for QinQ. So we are not configuring the VLAN type.eq. We need to use the QinQ configurations. So on this interface, what we need to do, you can display this. I don't need the VLAN type, and do VLAN type.eq. We need to specify the VLAN that we have configured, and then we'll go straight ahead and configure the QinQ stacking, or the QinQ PVID end. So at this level, if you run the command QinQ stacking, you can see that we have the PVID and the VLAN ID. So the PVID configures the outer VLAN. So we can start by configuring the PE VLAN ID, which will be 500. And then I've mentioned that we also need to configure the inner VLAN. So another command that we need to run is QinQ stacking VID. If you enter a question mark, we need to configure the starting VLAN, and then we can specify 2, the last VLAN that we need to allow. So the inner VLAN will be from 1 to 500. And the last step of this configuration is to bind the VSI. So I'll do L2 binding VSI 500. So we commit. So we'll do similar configuration on P02 on the interface facing the customer. So we have interface Ethernet 1/0/1.500 again. And then we need to do the QinQ stacking. PVID the same, it's 1. PVID should be 500, and the same way you have configured the other end. And then for another stacking VID, it's 1 to 500, similar to what we have configured on P01. And then we need to bind the L2. So it's L2 binding VSI 500. So I'll commit just to verify that I have committed on this end. So initially our VSI was not up. Let me see if I display VSI name 500. You can see that now our VSI is up because we now have the SC interfaces. So you can view more detail about the VSI with this command, display VSI name 500 verbose. It will give you more detail about the VSI. You have the description, you have the work mode is normal, the bridge domain, MAC LAN style is unqualified, encapsulation type is Ethernet, the MTU, and many more details. You have the pseudo state is up, local VC label, remote VC label. All these details you can view them when you run this command of display VSI name 500, then verbose of it. So on P01 we can display VSI also. Can display VSI name 500. It's up. We can do the verbose of it, and you can see all these details. You can see the signaling protocol up here. It is set to LDP. So the signaling protocol is set to LDP. The MTU, all the other details are merging. You can see the VSI state, the VC label, the peer type is dynamic, and then you can see the peer router ID, the VSI ID, you have the SC state is up, the pseudo information is down here. So all these details you can see them when you run the display VSI name, then VSI ID that you have configured. Another test that we can do is to ping this VPLS that we have configured. So on Huawei we have a command to ping the VPLS. So we can ping VPLS, VSI, and then VSI ID. So we have configured VSI 500, and then you can specify the peer IP. So the peer IP should be 3.3.3. You can see that we are able to ping from P01 to P02. On P02, we can also do the same, ping VPLS, VSI 500, and then the peer IP is 1.1.1. We are also able to ping from P01 to P02. So now to simulate the communication between the CEs using the QinQ that we have deployed, we need to configure some interfaces facing the customer. We need to configure interfaces from CEs facing the customer. So the first interface configuration that we'll be doing is .200, .300, and then we have 600. So on these CEs, I can just give it a name of CE01. And then we have interface. The first interface that we'll create is Ethernet 0/0/0.200. This one we need to configure the VLAN type .EQ 200 and give it an IP address. So we'll give an IP address of 172.200.200.1 mask it's 24. So we have configured an IP address. These are the configuration on the interfaces, on the first interface. We also need to do another interface so that we'll verify them both at once. We'll do interface. Let me undo the terminal monitor so that we are able to see the configuration clearly. So we'll create another sub interface using VLAN 300. VLAN type, I've said it's .EQ, VLAN ID is 300, and then we need to give an IP address of 172.100.100.1, mask is 24. The last interface that we need to create is .600. We'll specify the VLAN type .EQ 600. So this is to simulate that if you don't specify a VLAN within the range that you have configured on the PEs, services will not come up. The services will not flow through our backbone MPLS network. So we'll give it an IP address of 172.0.0.1, mask is 24. So I will save the configuration and display current configuration just to verify again. You can see that these are the configuration that we have on the router. These are the configurations for the three sub-interfaces that we are creating on CE01. So on CE02, we also need to create the sub-interfaces and assign IP address. So it's sysname CE02. Then the first interface, I'll undo the terminal monitor also. So we'll get this first sub interface, Ethernet 0/0/0.200. We are using the normal 802.1Q. This is not QinQ. So we'll do the VLAN type .EQ 200 and assign an IP address of 172.200.200.2, mask is 24. So we also need to configure the other two sub interfaces. .300 VLAN type .EQ 300 and then IP address of 172.100.100.2, mask is 24. And then finally our last sub interface, Ethernet 0/0/0.600 VLAN type .EQ 600, IP address of 172.0.0.2, mask is 24. So we have configured the three sub interfaces. Display IP interface brief. You can see these three sub interfaces configured on the CE. On C01, we can also verify display IP, interface brief. We have these three sub-interface configured on C01. So now we want to verify that our services, our QinQ service is working okay. So the first step we can do is to ping this .200 that is within the range. So we can ping .200.200.2. Remember, this is on C02. You can see that the service is able to go through without any issue. We can now ping the one that the .300, 172.100.100.2. That one is also able to go through without any problem. But when we try to ping the 172.0.0.600.2, the one that is with VLAN 600, we realize that our service is not able to go through because this VLAN is not allowed on the PEs. Remember, on the PE, if we display current configuration, you see that on the interface facing the customer, this is the interface, we have specified the allowed range of VLAN that can go through. So we have 1 to 500. So if it's not in this range, it will not go through. The services or the packets will be dropped on the PE. So we have verified that we are able to ping the 3. We are able to ping VLAN 200. We are able to ping VLAN 300, but we are not able to ping VLAN 600. You can also do a packet capture on the interface because we are not able to capture packets on the MPLS backbone, but we can do a packet capture on this interface and we will see the outer VLANs. So I can start my packet capture on this interface. I mean, we'll see the inner VLANs coming from the customer. So with the packet capture, I will only filter ICMP. We don't need to see everything. So I will filter ICMP. Apply. Still not picking. Okay, we have ICMP filtered only. So we only need to see the ICMP packets. We'll hide these also. Then we can have a ping too. So when we do a ping from 172.0.0.2, you can see that our ping is not going through and we are not even able to see the packets. But when we do a ping for the other two IPs, so we have 200, we have the ICMP packets, and you can see that this one is coming in with a VLAN ID of 200. If we ping the other IP, this was 200, we can ping 100. This is also coming in 100 with a VLAN ID of 300. So this one verifies that our QinQ configurations are okay, and we are having the inner and the outer VLANs on the IP packets transmitted from the two CEs. So this is how simple it is to implement QinQ on Huawei routing devices. Remember, we have configured our IGP ISIS, we have configured MPLS, LDP, and layer 2 VPN on the routers. And then we configure interfaces by enabling MPLS, assigning IP address, and also enabling MPLS LDP. Once you've done that, we need to configure remote LDP peering between the two PEs. If they are not connected, you really don't need to. You really don't have to configure the remote peering session because we'll have the local peering session between the two. And once you have done that, we're configuring our virtual switching instance, VSI or the VPLS on the PEs, and verifying that it's okay. You can see that we were able to ping the VSIs. Just to verify again, if you ping VPLS, VSI, the VSI ID was 500, and then you give the peer 3.3.3, we are able to send this traffic. And one good thing with VPLS is that you can be able to see the MAC addresses on the PE. So on this PE, we can display MAC address VSI 500, and we are able to see the MAC addresses that are coming from the connected CE and also from the remote PE. So you can see we are learning two MAC addresses on this interface. We have one on this sub interface facing the CE, and then we have one on this interface facing the P router. So we are able to see the MAC address, and this is the biggest advantage of using VPLS. It's easy to troubleshoot VPLS than the normal pseudo wire that we are not able to see the MAC address on the PE devices. So this is the end of our lab, and thank you for watching again. Please remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.